Hi, today we're going to learn how to do vectors in 3D. So this is basically everything we've just done, only now it's in 3 dimensions. So we have the x, y, and z. So you have 3 parts to each vector. So I'm going to have x, y, z, maybe d, e, f. So I have 2 vectors here just so I can show you what the formulas would look like. So magnitude, just like before, magnitude is going to equal, I don't know why there's not an equal sign. Magnitude is going to equal the square root of x squared plus y squared plus z squared. So it's exactly the same as what we were doing, only now we have a third one that we have to add in. Dot product is exactly the same as well. So you would do your x's plus your y's plus your z's. So this one times this one plus this one times this one plus this one times this one. Just like you did in a regular dot product, just one extra step. Okay? Unit vector, once again, same thing. You have your whole vector on top, all over the magnitude of your vector. So you do the magnitude over each one of them. So you're going to have 3 parts now instead of 2. Angle between vectors, same thing. You have the dot product over the magnitudes, and you do the cosine inverse, just like we did on the other ones. Projection is the same formula, the dot product over what you're projecting onto squared, the magnitude squared, times what you're projecting onto. There's just going to be 3 parts to it. The only thing that's different is when we're writing a vector, we have to have directional angles. So instead of being given an angle, sometimes you have to find angles. So directional angles are only in 3D. So a directional angle, you have alpha, beta, and gamma. So alpha is cosine inverse of x over the magnitude of your vector. Beta is the same thing, only it's y over the magnitude of your vector. And gamma is the same thing, but it's z over the magnitude of your vector. Okay? So whenever you are writing a vector in 3D, so you basically have the magnitude of your vector times the cosine of whatever alpha was. Then the magnitude of your vector times the cosine of beta, and the magnitude of your vector times the cosine of gamma. And we will talk about those here in just a second. Okay, so the first thing we want to look at is magnitude. So we have magnitude equals the square root of x squared plus y squared plus z squared. So let's say I have a vector, and my vector is 7, negative 3, 5. We're going to do it exactly the same way we did before. We're going to do square root of 7 squared plus negative 3 squared plus 5 squared. Be sure that negative is in parentheses when you type it in the calculator, and the squared is on the outside. So we're going to type in 7 squared plus negative 3 squared plus 5 squared, and we get 83. So we get the square root of 83. And then of course, if we can, we want to simplify this. I don't think it simplifies, but I'm going to double check. Square root of 83, you get 9 point something. So we go to y equals and type in 83 divided by x squared. Then we go second window, and we're going to type in 9 so that we can know where to start in our table start. And then second graph, and you're going to scroll up until you see a whole number. And of course, it's just square root of 83. It does not simplify. And so that is our magnitude. Okay, so now we're going to look at dot product. So it's the same thing once again. We have a vector dot another vector. So you're going to take your x's. So you're going to do 4 times 5 plus you're going to do your y's, 7 times negative 1, plus you're going to do your z's, negative 2 times 6. And you can type that whole thing in your calculator. 4 times 5 plus 7 times negative 1 plus negative 2 times 6. And we get 1. And that's how you do a dot product, exactly the same as we've done before. Okay, Okay, now we have a unit vector. Okay, so the unit vector is the same thing. We're going to take the vector over the magnitude of the vector. So first I want to find the magnitude of my vector. It's going to be the square root of 7 squared plus 3 squared plus negative 8 squared. So I'm going to type that in my calculator. 7 squared plus 3 squared plus negative 8 squared gives me 122. So I get the square root of 122. I want to see if that simplifies. So I get square root of 122 is 11 point something. Go to y equals, do 122 divided by x squared. Go second window and type in 11. And then second graph, and you're going to scroll up until you see a whole number. And this one does not simplify. So we're going to take our vector. So that's going to be 7 over the square root of 122, 3 over the square root of 122, and negative 8 over the square root of 122. And for my regular class, that is your answer. For my honors, you need to get rid of the square roots on bottom. So you get 7 square roots of 122 over 122, 3 square roots of 122 over 122, and negative 8 square roots of 122 over 122. The only thing is, 7 over 122 doesn't reduce, 3 over 122 doesn't, but 8 over 122 does. So we want to figure out what 8 over 122 is. And that's going to give us 4 over 61. So this becomes 7 square roots of 122 over 122, 3 square roots of 122 over 122, and this becomes negative 4 square roots of 122 all over 61. And that would be our final answer. Okay, so now we're going to look at the angle between two vectors. So it's the same formula, cosine inverse of vector u dot vector v all over the magnitudes of the two vectors. So we want to do vector u, so we have cosine inverse of v, or u dot v, so we're going to do 4 times negative 5 plus 7 times 2 plus 3 times negative 6 all over the magnitude of each one. So that's the square root of 4 squared plus 7 squared plus 3 squared times the square root of negative 5 squared plus 2 squared plus negative 6 squared. Okay, so we want to do the whole top. So in the calculator, I'm going to type in 4 times negative 5 plus 7 times 2 plus 3 times negative 6. Gives me negative 24. So I have cosine inverse of negative 24 over, and I want to find each one of these square roots. So I get 4 squared plus 7 squared plus 3 squared is 74. That goes in the first square root. And the next one is negative 5 squared plus 2 squared plus negative 6 squared, which gives you 65 in this one. You don't have to worry about simplifying these or even seeing if they reduce or anything, because we're typing them in the cosine inverse. So just like that, I'm going to type that in the cosine inverse. So second cosine of negative 24 divided by the square root of 74 times the square root of 65. And that gives me 110.25. And that is my answer. That is the angle between the vectors. Okay, the next one is projections. So on your projections, you're going to have v dot u all over magnitude of u squared times u, and that's if v is projected onto u. So it is on here, so we're going to use that same formula. So we've got v dot u, so v is 1, -5, 7, dot u, which is 4, 2, -3, all over the magnitude of u squared. So that's the square root of 4 squared plus 2 squared plus -3 squared. All of that is squared. Dot u, which is 4 to -3. Okay? So I want to do the dot product on top. So I do 1 times 4 plus -5 times 2 plus 7 times -3. All over, the square root and squared cancel, and I'm going to do 4 squared plus 2 squared plus -3 squared, which is 29. Get 29 on bottom. Dot 4 to -3. So on top, I'm going to do 1 times 4 plus -5 times 2 plus 7 times -3. That gives me -27. So I get -27 over 29 dot 4 to -3. And then you just multiply into each thing. And so I'm going to use my calculator because it's a weird fraction. So I get -27 over 29 times 4, which is going to give me -108 over 29. And the next one, I'm going to do -27 over 29 times 2, which gives me -54 over 29. And then I'm going to do -27 over 29 times -3, which gives me 81 over 29. And that would be my answer. Okay, now we're going to look at directional angles. So you're finding your alpha, your beta, and your gamma. So you want to find all three. So to find our directional angles, we need to find our magnitude. So we're going to find the magnitude, which I think we've already done, but we can do it again. So the magnitude is the square root of 7 squared plus 1 squared plus -8 squared. Okay, so that is 7 squared plus 1 squared plus -8 squared, which is 114. So we have the square root of 114. And we can leave it just like that. Don't worry about simplifying that one because it's going to go in a cosine. So to do alpha, alpha is going to be the cosine inverse of x, which is here. So this is x, y, and z. X is 7 over the square root of 114. Then beta is going to be the cosine inverse of your y, which is 1 over the square root of 114. And gamma is going to be the cosine inverse of -8 over the square root of 114. So I just type those in my calculator. So you do second cosine of 7 over the square root of 114, we get 49.03. So alpha is 49.03. And then beta, we're going to do the second cosine of 1 over the square root of 114. So beta is 84.63. And then gamma, we're going to do second cosine of -8 over the square root of 114. And we get gamma is 138.53. And those are your directional angles, your alpha, beta, and gamma. Okay, this is our last one. This one we're going to be writing a vector in 3D. So this one we are given the magnitude is 58 and we're given the directional angles are 76, 153, and 216. So we just plug them into our formulas. So our vector v is going to equal the magnitude of v, which we know is 58. So 58 times the cosine of alpha, which is 76, comma, the magnitude of v, which is 58, times the cosine of beta, which is 153. Then our last one is the magnitude of v, which is 58, times the cosine of gamma, which is 216. Okay? So now we just type those in our calculator. Please make sure your calculators are in degrees and not radians, or this will not work. So 58 cosine of 76 is 14.03. And then 58 times the cosine of 153 is negative 51.68. And then 58 times the cosine of 216 is negative 46.92. And that is vector v in this case. And that is vectors in 3D.